In this video, we're going to review how to name some molecules that are considered special cases. So our focus is going to be on the molecular elements, which could be diatomic molecules or polyatomic molecules. Remember, you learned about this in grade 10. It's called the Hofbrinkel elements. They're elements that don't exist as single atoms in nature, but rather exist combined to itself. So for example, H in nature exists as H2 in its gas form. So molecular element, again, is two or more of the same element chemically combined by a covalent compound because it's a molecule, just not a compound though, because it's two of the same elements. Diatomic molecules contain two of the same atoms. These same atoms. And there are 7 elements that occur as diatomic molecules, and these are the 7 here, the Hofbrinkel elements. So each of those molecules is basically two of the same atom connected to itself. So hydrogen gas, for example, is H2 gas. So if I were to say hydrogen in a chemical reaction, that refers to hydrogen gas, usually, unless I specify otherwise. And that would be H2 with a little gas in the brackets there. All diatomic molecules, with a couple exceptions, are gases at room temperature. Bromine is a liquid at room temperature, and iodine is a solid at room temperature. So there's also molecules called polyatomic molecules. And polyatomic molecules are basically two of the same nonmetals, or the same nonmetals connected to each other, but there's more than two. So for example, so poly means more than two, many. Di means two. So phosphorus is one of those polyatomic molecules. In nature, it exists as P4S, 4 of it connected to itself. And sulfur exists like that as well, S8 solid. So phosphorus solid and sulfur solid. So you do need to remember these molecules because when you write out chemical reactions, and I just say oxygen, for example, you'll know that that should be represented as O2, or chlorine as Cl2, or bromine as Br2. So to remember that, you can remember the trick Hofbrinkel, and then you can just add PS, or you can put PS to the front. PS Hofbrinkel. So we're going to go take a look at how to name these and how to write out these formulas, which is essentially what we saw here. So remember that diatomic elements are not, and same thing with polyatomic elements, are not considered compounds because a compound needs to have at least two different elements bonded to each other. How do we name these polyatomic elements? We simply name the element and then put the state. How do we write down the formula for a diatomic element? We put the symbol of the element with a 2 and then the state. Solid, remember, is S, liquid is L, gas is G, and AQ means aqueous or dissolved, but we're not really going to use that right now. So let's start off with hydrogen gas. That would be the name. Our formula for that is H2G. Now, in chemical reactions, we'll often just say hydrogen, and you should know that that does mean hydrogen gas. That's what that means. So you'd have to put H2G. The state at room temperature, well, gas. Bromine, liquid. So that's Br2, L, state at room temperature, liquid. Iodine, solid. Oops, no E at the end. So that's I2S, solid at room temperature. We have chlorine gas. So that's Cl2G. That's a gas at room temperature. We have fluorine, and that's also fluorine gas. So it's F2G, gas at room temperature. We have oxygen gas. And again, same idea. In a chemical reaction, we might just say oxygen. But you need to know that that's oxygen gas, which is O2 gas. That's a gas at room temperature. So far, let's see. We have Hoff, Bring, Kull. So we need nitrogen still. And nitrogen is a gas at room temperature. So it's N2 gas in its gas state. And let's see, what do we have? We have hydrogen, we have oxygen, we have fluorine, we have bromine, we have iodine, we have nitrogen, and we have chlorine. So we have the 7 diatomic molecules there. You know what? We'll add the polyatomic ones as well, just to remember those. So let's put sulfur solid. So this one is a polyatomic as opposed to diatomic, but same concept. Sulfur by itself would exist as S8 solid. And then lastly, phosphorus solid. Phosphorus by itself would exist as P4 solid. So what I want you to get is that this is when the elements are found by themselves, not in compounds. So for example, in a compound, sodium chloride, the subscript here is determined by the crisscross. But if it's just chlorine alone, or if it's just chlorine gas, rather, it's Cl2 gas. So this is chlorine gas, and this is sodium chloride. When it's in a compound, you do not worry about putting a 2 there unless it comes from the crisscross. Okay? So just remember that. Don't get confused by that. Some compounds, and you don't really need to remember this, but it's allowed for you to do this if you want when you're writing chemical reactions. You can represent them by their common name. So for example, instead of putting dihydrogen monoxide in a chemical reaction, you can put water. Ammonia, that's more the common name. Instead of putting nitrogen trihydride, you could put ammonia. Methane, instead of putting carbon tetrahydride, you can put methane. That's an organic chemistry name, and we'll learn more of that later on. Trioxygen, you can probably guess the formulas by now, is ozone is a common name, and you can put that in a chemical reaction, ozone. Calcium hydroxide, lime water. In a chemical reaction, I'd actually prefer you just put calcium hydroxide, but oftentimes in labs, you'll see add lime water to this. And what is that? Well, it's a solution of calcium hydroxide. And then hydrogen peroxide, you could call it dihydrogen dioxide theoretically, but in reality, it is a peroxide. So it's H2O2, and you can just call it hydrogen peroxide. So don't get confused by this and call it dihydrogen dioxide, because it is really a peroxide. So if you see H2O2, do not call it this, call it hydrogen peroxide instead. So in chemical formulas, if you see water, you can just call it water. If you see ammonia, you don't have to worry about calling it nitrogen trihydride, call it ammonia. If you see CH4, rather than say carbon tetrahydride, you can say methane. If you see trioxygen, you can call it ozone. Lime water, I prefer you just keep calling it calcium hydroxide for now, but recognize what it is. And then H2O2, just know it's hydrogen peroxide and not dihydrogen dioxide because it's peroxide. So you will learn more naming rules later on about peroxides and these things called hydrates. And in grade 12, there's another set of naming rules for these compounds called organic compounds, like CH4. That's why we call it methane, because it's from a organic compound set of naming rules.